Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Main 2020 Test 2 Code ENF. So let's start with the first question, students. Let us look at question number 26. Consider the following reaction. So we have been given a reaction in which this compound is made to undergo a series of reactions giving us A and B as the major product. So it was found that the molar mass of A is greater than that of B. We have to identify the correct option. So if you look at the reagents which is given to us, students, we have pH MgBr in presence of ether and it is allowed to react with an alpha beta unsaturated ketone. So students, if we talk about this Grignard reagent, the Grignard reagent, it likes to give a 1,2 addition product at the carbonyl carbon itself. Okay. So in the first step, we are going to get the structure. Now students, this is allowed to react with HI in presence of heat. So when the given compound is allowed to react with HI in presence of heat, two reactions will occur. Firstly, there will be a cleavage of this ether, and then secondly, there will be a dehydration of this alcohol. Okay, so we're going to get the oxonium ion firstly. Now students, if we talk about the hydrolysis of this ether, so this will give us the alcohol as it is an enol along with the liberation of CH3CH2I. Okay, now this enol will tautomerize to give us a keto compound. And further, when the alcohol is dehydrated, we are going to get an alpha beta unsaturated ketone. So the alkene will be formed at this position because of the conjugation with the keto group. Okay, so this is going to be the major product, which is A, as it has the greater molar mass, and this is going to be the major product B, which has the lower molar mass. So if you look at the options which are given to us, students, we can clearly see that option 2 is the only correct option among the given options. So for this question, we have to mark the correct answer as option 2, students. Let us look at the next question now. Question 27. Which of the given set of reagents is the most appropriate for carrying out the following conversion? Okay. So students, if you look at the compounds given to us, we have been given an alpha beta unsaturated carbonyl compound and it has to be converted into the product which is shown on the right hand side. Okay. So let's start with the first option now, students. We have ETMGBr. So the ETMGBr is going to generate ET negative, and that ET negative will attack the carbonyl carbon itself. Okay. So we are going to have the formation of this compound, and now when students HCl is added to it, the chlorine or the chloride ion will not get added at the terminal position because the carbocation will be more stable internally. Okay, so the chlorine will not be added at the terminal carbon, so this is not going to be an answer, students. If we talk about the second one, in the second one we have ET2CuLi. So this is the Gilman reagent. So the Gilman reagent, it gives us a 1,4 addition product, students. So unlike the previous case, the ET will attack at the alkene. Okay, so we're going to have the formation of a 1,4 addition product, students. So we're going to have the formation of this compound in the first step, and we can clearly see that this compound has a different carbon skeleton than that given in the question. So second option will not be an answer again, students. If we talk about the third one, we have ETLI. So the ETLI is also a strong reagent, students. The ET negative will directly attack the carbonyl carbon and it will be the same case as the first one. So we're going to have the formation of this compound in the third option also, and after the addition of HCl, the chlorine will get added internally and not at the terminal carbon as required in the question. Okay. So third option is also not an answer, students. If we talk about the fourth option now, so this is going to be the answer. So HCl is added first. So due to addition of this HCl, the chlorine atom will get added at the terminal carbon atom because of the carbonyl group. The carbonyl carbon will not allow the carbocation to form at this position because of its minus I effect. So in the first step, we're going to have the addition of HCl and the Cl will be added at the terminal carbon. And when further there is addition of ETMGBr, so the ETMGBr will get added in this fashion and it will lead to the formation of the desired product. Okay, So students, for this question, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 28. Consider the following reaction. So we have been given a dicarbonyl compound. It is allowed to react with KOH in presence of ETOH and heat. So major product P is formed, and the examiner seems to be interested in the statement which is not true for P. Okay. So if you look at the reaction conditions given to us, students, the examiner seems to be interested in the intramolecular aldol. So if we talk about intramolecular aldol, the attack of the nucleophile will obviously happen on the aldehyde. So the nucleophile has to be generated from the alpha carbon of ketone. So there are two possibilities. There are two alpha carbons present. So if we look at the terminal carbon, students, the terminal carbon, if it generates a nucleophile, then the ring formed will be a 7-membered ring. But if we talk about the internal carbon, the internal alpha carbon, so when the nucleophile is generated at this carbon, then we're going to have the formation of a 5-membered ring. So obviously 5-membered ring is preferred over a 7-membered ring. So the nucleophile will be generated from this carbon, from the internal alpha carbon to the ketone. Okay, so we're going to get this nucleophile, and this will attack internally at this carbonyl carbon to give us a 5-membered ring. So students, we're going to get a 5-membered ring, and then there will be a beta hydroxy, and then this will undergo condensation in presence of heat to give us an alpha beta unsaturated ketone. So students, this is the major product which is formed in this given reaction. Okay, so let us look at the statements given. So option 1, it says P can give positive tolerance test. This is not correct, students. P is a ketone. It will not give positive tolerance test. If you talk about the second option now, P can give positive iodoform test. So if you look at the compound P, so it can indeed give us positive iodoform test as it is a methyl ketone. So the second statement is correct. If you look at the third statement now, P is an alpha beta unsaturated carbonyl compound. This is also correct, students. The end product of any aldol reaction or aldol condensation is an alpha beta unsaturated carbonyl compound. And if you look at the fourth option, the difference in the molar mass of the reactant and the product is only of 18 gram per mole. So this is also correct, students. There is intramolecular dehydration occurring in this reaction. So only a water molecule will be lost. So the difference that will appear between the reactant and the product is only of 18 grams. So the fourth statement is also correct, students. So since for this question we had to mark the incorrect statement, so for this question the correct answer is option 1. Okay, let us look at the next question now. Let us look at question number 29 now. Which of the following elements are present in DNA out of carbon, nitrogen, oxygen and phosphorus? So students, carbon is present in DNA, nitrogen is present in the bases, oxygen is also present in the bases, also in the phosphodiester linkage, and phosphorus is also present, students. So all of these given elements, carbon, nitrogen, oxygen and phosphorus, are present in the DNA. So students, for this question we have to mark the correct answer as option 1. Okay, let us look at the next question now. Question number 30. Consider the following reaction. So we have been given a structure which is allowed to undergo acidic hydrolysis in the presence of heat to give us a major product P. So the major product P obtained from the above reaction is. So if you look very carefully at the given structure, students, it contains a hemiacetal. So we know that hemiacetals undergo hydrolysis. Okay, so the O will be protonated, giving us an oxonium ion. Then the hydrolysis of this hemiacetal will take place to generate the alcohol and the aldehyde which is present over here. Okay, so we're going to get this compound. Okay, now there is further H plus and heat in the system. So now there is an acid and then there is an alcohol. So intramolecular acidification will also take place, students. So we're going to have the formation of 5-membered cyclic ester. Okay, so this is the compound P which is formed at the end of the given reaction sequence. And if you look at the options which are given to us, students, we can clearly see that the correct answer to this question has to be marked as option 1.